Hello viewers, my name is Nicholas Majamani. I'm from Nelson Mandela Bay. I'm teaching at VM Kwinana High School. Welcome to the Eastern Cape Department of Education broadcast studio. Today my lesson is based on the technical science as a subject. I'll be presenting mechanics as our topic. Our subtopics that I will discuss are three, namely Newton 1, Newton 2, Newton 3. Let us start with the first topic. Newton's law 1, it states that an object will continue in the state of rest or uniform velocity unless it is acted upon by an unbalanced force. Newton's law is also supported or associated with inertia. Inertia is defined as the property of a body to resist any change in the state of motion or rest. Also, the mass is defined as a measure of inertia. We can also say inertia can be informed by a mass increase in mass can result to an increase in the inertia of a body. So we also use inertia to discuss why it is important to wear seatbelt using Newton's law. Then to proceed, we're going to discuss the Newton's law, our second topic, Newton's law 2. Then this is our Newton's law 2. Newton's law 2 is determined by a formula stating that the net force is equals to ma, where m stands for mass and a is denoting acceleration. Newton's law 2 states that when the net force acts on an object m, it causes object m to accelerate in the direction of the net force, such that we can compare the relationship of acceleration against the net force, where we can simply say acceleration is directly proportional to the net force, and the same acceleration is inversely proportional to the mass, meaning that an increase in the acceleration can result in an increase in mass, whilst acceleration, if it's increased, the mass will decrease. We're gonna move to the next slide, which is Newton's law 3. Newton's law 3 states that when an object A exerts a force on object B, simultaneously object B exerts an opposite directed force of equal magnitude on object A, so such that those two forces, one can be an action and then the other one can be a reaction, hence we call them action-reaction pairs. There are four important properties of action-reaction pairs in law 3. We have to know that the forces that are acting in this regard, they are acting on the same line along the same plane. Also, the forces are acting simultaneously. These forces are acting at the same time. That's what we mean by simultaneously. Also, the forces act in opposite direction. Lastly, object A exerts a force on object B, while object B exerts a force on object A. This is an emphasis that these forces are going to different direction. Okay, to continue with our lesson, let us try to answer questions of multiple choice questions that I've cut from various question papers of previous years. Question 1, various options are provided as possible answers to the following questions. Choose answer and write only the letter next to the question number. Then the first question, scenario number 1.1, 2 crates of masses 120 kilograms and 65 kilograms are resting on a smooth horizontal surface. When a force of 600 newtons is applied on 120 kilogram crate, the whole system accelerates as shown in the diagram below. The next statement, F65 is the force exerted by 65 kg crate on the 120 kg crate. Which one of the following diagram best represents a free body diagram of all the forces acting on the 120 kilogram crate? So it is possible that there are 4 forces acting on the crate, which is 120 kilogram. Mind you, the forces when are drawn, because our options are free body diagrams. So when the forces are drawn, the object should be represented with a dot, and all those forces should be drawn from the object away from the object. So if we look at option A is saying 600 is going to the left, of which that is not the case in the diagram. 600 must go to the right. So A can be the correct answer. Let us look at option B. Option B is saying the force of 65 kilogram is going to the left, of which is correct. And then the force of 600 newtons is going to the right, of which that is the correct case. And then upward is newtons, normal, and then downward it's force of gravity. That is true. So I may choose B as the correct answer. But let us look at other options, whether they will give us incorrect answers. In question C, 600, the force that is representing 600 is drawn towards the object, of which that is incorrect. All the forces must be drawn from the object away from the object. So that 600 is wrong. Then D, option D, 600 is going to the direction of left, of which that is not the case according to the diagram given. Hence, option B is the correct answer. Let us proceed to the next question. The next question is 1.2. Newton's third law of motion refers to action-reaction pair of forces. Which one of the following statement is incorrect for the action-reaction pairs in the picture? As I stated that the properties of the forces involved here, they are acting along the same line. That was number 1. And they are acting simultaneously at the same time. They are opposite. So in the following options, we have A, they act along the same line, of which that is the correct statement, of which we are looking for the incorrect statement. B, both forces acting on the hammer simultaneously. It can't be the case, because in this case, the hammer is exerting a force on the nail, whilst the nail is exerting a force on the hammer. So the incorrect answer here, I may say it's B. And then let us look at others. Incorrect answer here is B. Let us look at others. Option C, these forces act on the hammer and the nail simultaneously. That statement is correct. Then D, these forces act in an opposite direction, of which that is the truth. Then let us proceed to the next question. Question 1.3 is addressing Newton's law of motion, the first law. Newton's first law of motion implies that an object will continue moving at a constant velocity as long as the net force experienced by these objects is exactly equals to 0. So let us look at answer number A. Sum of all these forces acting on the object is 0. B, the net force experienced by the object is greater than 0. That's not correct. C, the net force experienced by the object is less than 0. It can't be. D, sum of all the forces acting on an object is greater than 0 but less than 1. So I've already mentioned that A is the correct answer. Sum of all the forces acting on the object must be equals to 0. Let us proceed to our question 1.4. Let us continue with answering question 1.4. Acceleration is defined as the rate of change of option A, the speed, option B, the velocity, and option C, position, and option D is the distance. Let me remind you that in grade 11, because most of our definitions are based on the formulas, acceleration is equals to delta V all over delta T. So mind you, in our formula, we are dividing with time. That is actually the rate. So here, this is acceleration is the rate of what is on the numerator, meaning our acceleration is the rate of change in velocity. So our correct answer here in 1.4, we're gonna choose B as our best option. Let us continue. Question 1.5. If an object of a mass m is at rest, the following statement is true. The net force of the object is 0. B, the only force acting on an object is the normal. The applied force is greater than the friction force. The only force acting on the object is weight. Let us look what is a key here. The object is at rest. Mind you, when the object is at rest, acceleration is equals to 0. There is no change in acceleration. Also, when acceleration is equals to 0, the net force or the resultant force must also be equals to 0 because the forces are balanced. So this is taking us to question option A. The best option here is A. The net force of the object is 0. Hence, A is the correct answer. Let us move to the next question. Question 1.6. 1.6. An object of a mass m rests on the flat table. The earth pulls this object with force of mg, which is known as action force. Which one of the following statement gives the best description of reaction force? Here, the action force is the force of gravity, which is Fg, or they say it's weight. So the force that is retaliating, or the force that is an opposite to the force of gravity, it must be an upward force. So let us look at the options. The table is pushing the object up with a force mg. The object is pushing the table down with a force mg. The table is pushing the floor down with a force mg. The object is pulling the earth upward with the force mg. The best answer here must be informed by an option that is opposing the action force. Mind you, the action force is going downward. It is expected that the reaction force must be upward. So we're going to look at option A and option D because they are the ones that are having option upward as an answer. But let us look at the best option. When the object is resting on a table, then the force that is exerted on an object, it is exerted by the surface of the table on the object. So that has nothing to do with earth. The only force that is exerted by earth on an object, it is always downward. Hence, option D will be the incorrect answer. Therefore, option A will be the best answer for this question. Then moving forward to question 1.7. A man lifts a 60-kilogram load with a rope at a constant velocity. Then you underline that word because it's one of the key words. What is the tension force in the rope? Ignore air friction. In this case, the tension is between the man's hand and the 60-kilogram load. Now it's a question of the tension can be equal the downward force. Because of this, this is having a mass of 60 kilogram. Fg is equals to mg, where m stands for mass and g stands for 9,8. So in the place of mass, we can put 60 kilograms multiplied. G is a constant, which is gravitational acceleration. Our Earth's gravitational acceleration is equals to 9,8. So 60 times 9,8 is probably 588. Then it's a question of Fg will be downward, but the rope, the tension on the rope is moving upward. So therefore, this Fg will also be equals to our tension, whereas our Fg is going downward, therefore our tension will be going upward. So we'll choose our D, our C, our C as our best answer or the correct answer. Let us wrap up. So our last question is 1.8. Then 1.8, an object's direction of motion is always the same as, this is addressed by Newton 2. Newton 2 is stating that when an object acts on when a net force acts on object M, it causes object M to accelerate in the direction of the net force. Hence, our object's direction here of motion will be the same as the resultant force. So if we look at our options, we are given A as the applied force acting on the object, which is not correct. A non-zero force acting on the object, it is incorrect. The equilibrium of forces. So the last one, the resultant force acting on an object, as it is stated in Newton's law 2. So our correct answer is D in this question. Okay, let me leave you with the 4 last questions so you can give correct answers on the comment sections. So this might be your own work. Thank you. So we have come to the end of our lesson. You can leave your questions on the comments. Don't forget to leave the name of your school so we can shout out. Please share and recommend. Subscribe to our YouTube channel. Thank you for watching. See you on the next lesson.